Okay, so we're doing section 7, which is what was section 7? I guess it was doing the Taylor polynomial approximations. I thought I recorded this before, but apparently I hadn't, because I went to do the recordings and they weren't there anymore. So I don't know what happened. So I'll have to record them. But I've already done the solutions, so I'll move a little faster than I normally do. Just you can always pause it. And just get my tablet working here. Okay, so this is a Maclaurin polynomial. We're doing it at e to the minus x. The book does e to the x. So, and we have 5 derivatives. So you take the function e to the minus x, and then you take the next 5 derivatives. So e to the minus x, the derivative of e to the minus x is minus e to the minus x. That's because you used the chain rule, and u of x would be negative x. So when you take the derivative of that, you get negative 1, so that's where that negative sign comes from. When you do it again, you're going to get a negative times a negative, which will be positive, and then you'll get a do it again, so it alternates between negative and positive. So those are the derivatives. Then you evaluate the derivative at 0 because it's a Maclaurin series. So e to the 0 is 1. So this part is always 1, and you get plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. So those are the coefficients. So the nth polynomial, which is the approximation to this function around, in this case, x equals 0, is f of 0 times f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 over x cubed over 3 factorial. So, and then continuing on, so in our case, f of 0 is 1, f prime of 0 is negative 1, so we get a negative sign times x plus f double prime, which is 1, times x squared over 2 factorial. You get x triple prime, negative 1 times x cubed over 3 factorial. And it just follows this pattern. So e to the x was 1 plus x squared over 2 factorial plus x cubed over 3 factorial. When you have e to the minus x, you get this alternating arrangement. Number 17 is the sine of x. And we want 5 terms. So we start with the function, the sine of x. The derivative of the sine is the cosine. The derivative of the cosine is negative the sine. The derivative of the sine is the cosine, but you've got this negative sign which you carry down. The derivative of the cosine is negative the sine, so I'll have negative times negative gives me positive. And you notice that I'm back to the sine, so it just repeats itself after 4 derivatives. And then we evaluate the function and the derivatives at x equals 0, since we're dealing with a Maclaurin series. So we do the sine of 0, which is 0, cosine of 0, which is 1, negative the sine of 0 is negative 0, so 0. Cosine of 1 is 1, so you get negative 1. And then you start over again with sine, so you get 0, 1, 0, negative 1, 0, 1. So then you plug it into your expression here for the Maclaurin polynomial. So this is f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial plus x, the 4th derivative, times x squared over 4 factorial plus 5th derivative, which is 1 right here. 5th derivative is evaluated at x equals 0. And so this term, and this term drop out because they're just 0, and you just end up with these odd powers. So 1 to the first, x to the first power divided by 1 factorial, but we just rewrite it as x, and you get negative x cubed over 3 factorial plus x to the 5th over 5 factorial. So they didn't ask us for it, but once you see this pattern, the next term is going to be x to the 7th over 7 factorial, and you're going to make it negative. And then the next one after that's x to the 9th over 9 factorial. And it just keeps going on like that. But they didn't ask for those. And 21 is also a Taylor polynomial. And this is just more difficult because you got this product. So the original function, we have to use the product rule for differentiation. So you take x squared times the derivative of e to the minus x, which is negative e to the minus x, plus the derivative of this part, which is 2x times the second term, e to the minus x. So that's f prime of x, and here I'm just simplifying it by moving the negative sign out in front. Okay, now we have two products, so we have to do this product rule twice. So here we take x squared times the derivative of e to the minus x, which is negative e to the minus x, and multiply the negatives together to give us a positive. So this first part of the product rule gives us that. The second part, you take the derivative of this, which is 2x. The second part stays the same, so you get negative 2x e to the minus x. So that's the result from differentiating this. And then you do the same thing here. So you take 2x, multiply by the derivative of e to the minus x, which is negative e to the minus x. And then you take the derivative here, the first part of the product, which is just going to be derivative of x is 1. So this becomes 2. And then the second part is just e to the minus x. Notice we have negative 2x e to the minus x and minus 2x e to the minus x. So that becomes negative 4 e to the minus 4x e to the minus x. So these four terms can be simplified down to 3 terms. And then we need one more derivative. So we do it again. So we actually have two product rule and just a simple differentiation. So we've already done this before. We've done the x squared e to the minus x. So that's this part. So we can just copy that down. This part is exactly that part. Then we have to do this part, which we kind of did up here. So you get negative 4, and then you take the derivative of this product. So you take x times the derivative of e to the minus x plus the derivative of x times e to the minus x. And then the last one is just you get a negative sign from taking the derivative of this part, so it becomes negative 2 e to the negative x. You multiply all the terms out. So this one's this one's that, this one is that, this multiplied by that uses that, and then I got the last term. So I've got 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5 terms. And I've just aligned these so we can add them together. So this one just comes down. 4 plus 2 is 6. Negative 4 minus 2 is negative 6. So those are the actual derivatives. Then you evaluate the derivatives at x equals 0. So this goes to 0 because you've got one term being 0. And this also goes to 0. So both of these are 0. So f prime of 0 is 0. Also f of 0 is 0 because this part's 0. 0 times anything is 0. Okay, then you go to the second derivative. We do have one term that doesn't go to 0, which is this last term. These go to 0 because you have 0 squared, you have 0 here. There's no x here, so we have 2 e to the 0. E to the 0 is 1. 1 times 2 is 2. So I finally get a coefficient. And for the third derivative, this goes to 0, this goes to 0, this goes to 0. Well, actually, these both go to 0. This one doesn't. E to the 0, e to the minus 0, which is e to the 0 is 1. So we get negative 6. And these turn out to be, if you actually did the next term, which did we do? Yeah. So if you do the next term, the fourth derivative, which is taking the derivative of that, which gives that, and the derivative of this, which gives that, and the derivative of that, which gives that, and you add them together, you get this as your fourth derivative. Again, these two terms drop out, and this one becomes 12. Because you get 6 here, 6 there, so it's 12. So again, you plug in 0, let me just get 12. Okay, so f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus x triple prime of 0 times x cubed over 3 factorial plus the fourth f4 prime times x to the fourth over 4 factorial. So these drop out. 2 over 2 factorial is 1. 6 over 3 factorial is also 1. 4 factorial is 24, so you get 12 divided by 24, which can be simplified down to a half. And so that's your final answer. So we're going to 26, which is a Taylor series. So we have four derivatives. We're going to take it around x equals 2 instead of x equals 0. So we start off with our original function. I rewrite it as 2 times x to the minus 2 power, so I can take the derivative. So when I take the derivative of this, I'll get negative 2 times 2, which is negative 4. Reduce the exponent by 1. Next time I take negative 3 times negative 4, gives me 12. Reduce the exponent by 1. Negative 4 times 12 is negative 48. Reduce the exponent by 1. And negative 5 times negative 48 is positive 240. Reduce the exponent by 1. So you can rewrite these by moving the negative exponent term to the denominator. Then we're going to evaluate these at the midpoint or the center, which is 2. So we just plug in 2 into each one of these expressions. So we'll get 2 over 2 squared, which can be reduced to a half. Here we'll get negative 4 over 8, which is negative 1/2. 12 over 2 to the fourth, which is 12 over 16, which can be reduced to 3/4. Then we have negative 48 divided by 2 to the fifth. Reduces to that. And the final one is 240 over 2 to the 6, x to the 6 or 2 to the 6. And reduces down to that. So then all we have to do is take f of 0 times f of 2 times f prime of 2 times x minus 2. F double prime of 2 times x minus 2 quantity squared over 2 factorial minus f triple prime of 2 times x minus 2 cubed over 3 factorial. And then the final f prime of 2, f to the fourth derivative of 2 times x minus 2 to the fourth power over 4 factorial. And do a little simplification. Because 2 factorial is 2, so you get 3 over 4 times 2, that's 8. Here we get 3 over 2 times 3 factorial. 3 factorial is 6, so you get 3/12, which is 1/4. And here we have 15 over 4 times 4 factorial. 4 factorial is 24 times 4 is 96. So you can divide both 15 and 96 by 3, and it simplifies as such. Okay, problem 29. This is our function, number of derivatives, the value of x, which we are centering this series. You know, we couldn't do around 0 because the natural log of 0 is negative infinity. So the derivative of the natural log of x is 1 over x. Now it's a polynomial. So I rewrite it as a polynomial of x to the n. So when I move this to the numerator, it becomes -1. Then I take the derivative, so I'll have -1. That's where the negative sign comes from. Reduce the exponent by 1. Then I can rewrite it as -1 over x squared, positive x squared. -2 times -1 is positive 2. Reduce the exponent by 1. Move that to the denominator, make it positive. -3 times 2 is -6. Reduce the exponent by 1, rewrite it as such. Now we have to evaluate these functions and the function and its derivatives at x equals 1. So here I'll get the natural log of 1, which is 0. 1 over 1 is 1. -1 over 1 squared is -1. 2 over 1 cubed is 2. And -6 over 1 to the 4th is -6. So those are my coefficients. So my polynomial with 4 derivatives is 0 plus 1 times x minus 1. Again, we're subtracting the number that we are centering this thing around. That number here is that number, so we always subtract it. So we take this number, second derivative at f at x equals 1 times x minus 1 squared over 2 factorial. Take this, 2 times x minus 1 cubed over 3 factorial, -6, so forth and so on. And then you can simplify it down. So you get 1 over 2 factorial, which is 1 over 2, that's a half. 2 over 3 factorial, so 3 factorial is 6, so you get 2/6, which is 1/3. Here we get 6 divided by 24, which is 1/4. And that's it.